Hello and welcome to today's webinar, Optimizing Your Yodlee Interactive API Integration. This is Grace Francisco, Director of Developer Strategy here at Yodlee, and I'll be your host for today. If you have any trouble with the audio or visual portions of this broadcast or have a question, please post those in the Q&A panel, which you will find access to in the drop-down panel at the top of your screen, or dial 0 for an operator. This webinar will be recorded and available to you after the presentation. Today I'm excited to introduce our presenter, Jeff Schulte, VP of Operations, Scalability, and Architecture at Yodlee. He's responsible for system performance and operational scalability of Yodlee's SaaS-based production infrastructure to support usage growth across a global network of millions of consumers and growing. Jeff has more than 15 years' experience building, delivering, and operating highly scalable and highly redundant mission-critical software applications and systems. He's been a key driver in the Yodlee operations organization, building performance engineering and capacity management functions from the ground up to support every client launch since 2004. Prior to Yodlee, Jeff spent 8+ years with Accenture, building and delivering systems for large customers including Microsoft, Agilent Technologies, BA Systems, and eBay. And without further ado, over to you, Jeff.
Thank you, Grace, for that introduction. I'm really glad to be here and have the opportunity to walk through with everyone on this call the best practices for how to make the Yodlee API perform optimally. For today's agenda, we're going to be going through two major topics. The first one is tips on performance. So we're going to go through 5 quick tips on how you can make the API perform as fast as possible. Secondly is we're going to go over a new methodology for doing data extracts. And we're going to spend some time on that because a lot of customers really are interested in using our API to extract data to a local data store. So let's start off by getting into the best practices for utilizing our API. So starting off, I wanted to go over just an overview of our API, just a general overview and some themes for the presentation today. So starting off, let's talk about some key attributes of the Yodlee API, some key positive attributes of the Yodlee API. First of all, it's a web service and it's built for real-time applications. The Yodlee API, all of our hosted applications are built using the Yodlee API. It's been around for many of the APIs that you're currently using that are most commonly used have been around for 8 to 10 years themselves. It's built to be made for online presentation of your own applications. The Yodlee API is highly flexible. Most of the APIs have a lot of options, a vast number of options on what sort of data you can have returned back to you. And finally, the Yodlee API is fast and scalable. But the debate here is it always fast and scalable? And so in this presentation, we're going to be going over how to make sure it's fast and scalable and avoid some of the pitfalls that can make it actually not be very scalable. So some of the themes for achieving high performance with the Yodlee API. It all starts off with optimizing the server-side processing. This is the black box of Yodlee, which you really have no control over how fast our systems are. But what you do have control over is how you use our API and what data you're returning. So we're going to go over how you can optimize how fast we return data back to you. The second part of this is how do you optimize the network. So the network in between your client and our services. How do you optimize the network? Well, you do that by returning as little data as possible. The smaller the package that we send back, the faster it's going to be. And finally, by optimizing the server-side processing and optimizing how you use the network, this will help minimize your client-side processing time. So the theme here is how do we do this? The real theme is only get the data you need. So let's jump straight into tip number 1, caching your sessions. This tip has to do mostly with the login API, and we'll go over the co-brand login as well as the login API itself. So starting off with the co-brand login. The co-brand login is when you call co-brand login. The co-brand login session is valid for 2 hours. The best practice for using the co-brand login API is to only create one session per site or per server instance. And then what our best practice is to reuse that co-brand session for all subsequent API calls. It's amazing how many of our customers, or how often we run into this situation where folks who are new to the API will actually make the co-brand API call as a subsequent call to every single user login call. And that's really not necessary. So our best practice is to create a co-brand session on each server instance, cache that session locally, and then create a new co-brand session before the previous one expires. And we document in our best practices to do that after 90 minutes. Give yourself a half-hour buffer before the co-brand login really expires. The next part of the caching sessions tip is on the user login, the user login API. So the user login is valid for 30 minutes after the last activity for the user session. So we maintain the session, we keep it active 30 minutes after the last time a call is made utilizing that session. And the absolute timeout for the user login session is 2 hours. So our best practice is to create one user session per user and to reuse that session for all subsequent API calls for that user. This is all very intuitive stuff. Most customers do a great job of doing this, but we do have, it is very easy to, think that you have to create a new user session for every single login call. And that's really unnecessary. You just need to cache the session locally and reuse it for all subsequent calls for that user within that time period where you're interacting with that user. So we want to make sure we provide metrics to support all of the tips we have. So the overall response time for the login API call is 175 milliseconds. This is across our entire network and all the millions of login API calls that get made per day. 175 milliseconds. That's decent. We want to, and for most customers, that's pretty acceptable. And anything under 200 milliseconds is going to go unnoticed. However, I just do want to note that I would like to eventually get that down to 50 milliseconds, but that's a different conversation. Now, an example of the next line here is an example of a customer who uses the login API call prior to every additional call. We've seen situations where customers are actually adding 3/4 of a second or a second to the overall interaction time just because they're calling the login call every single time. So this is an example of an actual customer that's averaging close to 3/4 of a second in login calls for a user session. Another best practice is a thing we've seen is people will try to parallelize the login call and do that while making subsequent calls. And so we do see scenarios where we'll see a login call for the same user made simultaneously at the same time. And this will also add to the response time. So you can see it can add a couple hundred milliseconds to response time. 364 milliseconds is an example of what we see as an average when people are making concurrent login calls. And finally, for the co-brand login API, the best practice of just caching your co-brand login API, you're only going to save 84 milliseconds per interaction, but 84 milliseconds is better than nothing. And I'm into saving every single millisecond possible. All right, let's move on to the next topic, the next tip, and this is to avoid using transactions in data services calls. Now, the data service calls, get item summaries and for SOAP and account summary all for REST, and get item summary for item 1 and for REST and SOAP for getting a single item. These are our most popular calls in the entire network. You can't do anything in the Yodlee system unless you have the account level information. So these calls, everyone makes them, and this is the most popular call in our entire system. Now, the issue with the summary call is it's a long-standing call. Get item summaries. This call has been around since I think 2005 as an API call. And when it was originally built, it was built to be massively flexible. You can return data at pretty much all levels of the account, from the account level to the transaction level to the statement level, holdings, and it gets into multiple levels for loans and mortgage and insurance. And all those levels are documented in our Java docs. Now, our best practice is pretty simple. Use the item summary calls or the data service calls to only return the account level information, and to utilize the transaction search service for transactions. So that's a pretty simple concept. But so what we recommend is to use DataExtents. And for bank, card, mortgage, loan, and insurance, use DataExtent level 0 only, and that will just return you the account level information, which is what most people are interested in, and it'll do it very fast. And then for investments, use level 0 and level 2 to return only the accounts and holding level information. So those are the best practices. Now, first, our new site level APIs, get item summaries for site. There really is no need for you to do anything. We've already taken care of this in the APIs themselves. Transactions are excluded from these APIs, so there's really no need to worry about the extents in these APIs. So we've included a few code examples here. The first example is for SOAP, and this shows the two different methods for how you can pass in extents to the API. The first method is to do a leveling method, a start level and an end level, and this example shows using start level and end level 0, which is what our best practice is for most of the containers. And we're also showing here how to do a different method, and that is to include the elements from the DataExtent in an array. And so the example below shows for the investment container using element 0 and element 2 to return only accounts and holding information. Here's another example. This is showing an example that you could use in your own code for decisioning this using the REST API. And this example illustrates how you add parameters to the extent, and the default being a start level 0 and an end level 0, but if having conditions based on the container. So if the container is credits or credit cards, you can use level 0, and we put in here this example using level 4 to return statement level information in addition to the account level information. We've also shown here stocks, which is our name for the investment container, and we're showing an example of using level 0 and level 2 to do accounts and holdings as well. So here's some data that shows the support for the data service as a function of the size of the return. And the concept is really simple. This graph is actually an array across our entire client implementation, all of the Yodlee customers, showing the average response time as a function of the size that is returned back from the API. And the concept is pretty simple. The less information, less data that you return back in this API, the faster it's going to be. So if you want your account level information to return back really fast, pass the proper extents, and you're going to get back the data in likely under a couple hundred milliseconds. And avoid doing transactions. We do have a few customers that are including transaction level information, and what we see is that the response time averages close to 10 times more for the data service functions when you include transactions versus excluding them. And on top of this, this is just the data. This is an example of the server processing as well as the transmission time from the Yodlee side. This is taken straight out of our access logs and in our analytics system. So you have to also tack on the time in client-side processing. If you're processing 36 KB of data, The client-side parsing and processing is going to be much faster than if you're processing, in our example here, 500 KB of data if you're including transactions. All right, let's move on. So you can see we're kind of traversing down the stack of the data that people most often retrieve. You log in to Yodlee via the API, then you use data service to get the account level information. And then the next step is to get the transaction level information. So our transaction APIs, execute user search is the API call. And here's our best practices. For online or real-time usage, so if you're using the API real-time to present data to your customers, our recommendation is to limit the response of transaction search to between 1 week and 1 month as the default for display. This is a best practice that's pretty common across most banks and online banking websites. And we recommend this because most customers really want to see their most recent transactions. That's by default what they're looking for when they want to see their transactions. And if you limit to 1 week or 1 month, your chance of getting a really fast response is going to be pretty good. And now our next best practice is to provide your users with the ability to use to interface with the application and ask for more transactions as a subsequent action. So an example would be, if they want to see more transactions, 3 months, 6 months, 1 year, or all transactions, or if they want to search any of those, do an actual search, a text search, a date search, transaction amount search, you name it, to offer that as a subsequent action. That's our best practice. Now, for large transaction selections, if someone selects to view, say, all their transactions, we may return back a response. Well, our default is return back a response of only 500 transactions. But if we're returning back 500 transactions, rather than managing the pagination of those transactions and caching on your own side, we recommend to use our API to limit the response to 50 transactions at a time, and then to use the Get User Transactions API call to paginate through the results set. And finally, apply this logic at the account level if you do transaction search for all accounts, or if you do transaction search based on a grouping of accounts. This best practice applies for all those different scenarios. Now, for data extracts, we have a lot of customers, especially in the API world, who really prefer to extract the data down to a local data store and to provide their user interface to their customers from the local data store. So if you're using Yodlee and extracting data from Yodlee, our recommendation is to extract 7 days of transactions overlap from the last successful time you did an extract from us. And you have all the data from us from the last time we refresh the account. So a simple logic is based on the last successful refresh of Yodlee that we have on our system, overlap by 7 days when you're extracting transactions. So this will ensure that you'll get those 7 days. You'll be able to do the matching on your side and make the API work really fast and make the whole processing go really quick. And then the other best practices, of course, if you're adding an account for the first time and you're extracting data to your own local system, just use the transaction search to get all the data the first time around. So an example, here's a sample usage of the transaction search API. The transaction search API it's really built and indexed off of the post date and the transaction date. And so we recommend using the post date as the filter, and here's an example of limiting the response back to basically the last month of transactions. Going from the 24th of February to today, and this is an example that would return you back the last month of transactions. Pretty straightforward. Now, to data supporting this is pretty self-explanatory. The more transactions that you return back in your response, the longer the API is going to take. And so we have different buckets here. You can see that that if if you have, for instance, between 0 and 30 days of transactions, the size of the call is going to be under 100 KB on average, and the response time is going to be, on average, well under 200, well under a quarter of a second. As you bring back more transactions, the response time is going to take longer. And if you're looking to get a 365 days of transactions, you can expect the response time to average somewhere in the ballpark of 4 seconds per call, and for the size to be well over a megabyte. Okay, let's move on to the next performance tip, and that is to use Gzip compression. So, so we get in. So this performance tip pretty much spans across all of the APIs that return a lot of data. Is this going to help the login API? No, not really, because that API doesn't really return a lot of data. But it really benefits the data service and the transaction search service, as well as the content service APIs. The APIs that will return back large sums of data. So here's a real-world example of a customer that was interacting with our API without Gzip, and then changed to their API to use Gzip. And what we typically see with Gzip compression is that we see close to an 8x improvement, or an 8 times reduction in the size of the response. And this actually applies both to the JSON responses as well as the SOAP responses. So, definitely this is the best practice. We recommend doing it. A lot of customers are starting off very small, and they're well under 1 megabit per second, and maybe they're not noticing this is costing them much. But definitely, as you're scaling up, this is something to consider. A lot of data center providers, a lot of cloud providers will charge $100 per megabit per second. At a really low commit rate, and this is a good way to save yourself some money in your data center costs or your processing costs by very simply. So we recommend to just out of the gate implement Gzip compression and help out your performance. Okay, tip number 5. The last tip in this section is for the content services API calls. So the content services API calls return back all of the content services or the data services that we support in our network. These calls, for customers that are configured to enable pretty much all the containers, these calls will return, at least currently, over 28 megabytes of data, and that's constantly growing. We're constantly adding new content services, so this is one of those API calls that's going to constantly grow, and 5 years from now it'll probably be well over 50 megabytes. So our best practice is to leverage tip number 4, use Gzip to compress the response. That will knock off a lot of the transmission time, and out of the gate you're going to gain a lot of performance and make this API faster. Our next tip is to content cache the services locally, and to do this once per day. So, our recommendation here is the content services, they do change. We on average probably, we probably have a 30 or 40 changes per day. But our recommendation is just cache the content services once per day per site, or however your caching mechanism works, and just to leverage your local cache for content services. Now, for container-based implementations, we recommend using the get all content services by container type 2, and this will allow you to return back the data in chunks. So you can return back the bank data, the card data, the investment data, etc., each individually, and it makes the transmission and the processing a lot easier. We found a lot of customers really benefit from doing it this way. And our final tip is to avoid usage of the content service as part of the API flow. We do see sometimes customers will interject a content service call, in the flow of a user interaction, and you can save yourself some time and improve your performance by just leveraging your own content cache of your own content services. So in summary, we have the 5 performance tips, starting with co-brand login and user login. For co-brand login, really simple: cache your co-brand context and reuse the co-brand context for all subsequent API calls. Renew the co-brand context every 90 to 100 minutes, and you'll be in great shape. For the user login, reuse the co-brand context for each subsequent API call for a user. Avoid using concurrent login calls or calling the login API prior to every single API call. For the data service, our recommendation is to use DataExtents. We recommend using DataExtents level 0 for bank, card, loan, and insurance, DataExtents level 0 and 2 for investments and holdings, and to leverage the transaction search API for transactions. With transaction search service, we have, for online users, our recommendation is to limit the response to between 1 week and 1 month based on the post date for online usage, and for data extracts to limit to 7 days of overlap. And finally, use Gzip compression flag to reduce your response time, the size of your response by 7x, and cache your data services locally. So hopefully you found all the performance tips to be fairly simple and fairly intuitive, and hopefully folks on this webinar are getting a lot of benefit out of this. So let's move on to our next topic, and that is API data extracts, and kind of our new support for this way of getting data back to your local store. So let's do a quick overview of data extracts in our historical way we've marketed this product. So currently in the standard contract, we have a limit for all API customers for extracting data or using a process to extract data to 3 accounts per second. Now, I want to clarify this because people do get confused about this. For API customers, if there's an end user on the other end, there is no limit to how often you use the API. But we do have a limit if you are using the API in an automated fashion to extract data or running a batch job against the service to extract data. It's 3 accounts per second. That's the default. Now, for customers that require to go above 3 accounts per second, our standard requirement has been to purchase and implement the Yodlee Data Extract product, which is a file-based product. So we've in the past forced our customers to implement another interaction with Yodlee, and that is to process files. So that's the other option is to spread your extracts through the entire day to stay under the 3 accounts per second limit. That's another option that customers have chosen to do. This method is essentially shooting in the dark. Once a day, you're coming in, checking on updates of account information and bringing that data back to your local data store. So those are the options currently, or historically. Now, we are doing some revamps to our Yodlee Data Extracts product, and we're pretty excited about this. We still do have the 3 accounts per second limit for automated data extracts. That's still in our contracts. However, we are providing options for using the API as a permanent solution for data extracts. So the one option that I want to discuss most is what we're calling synchronized data extracts, which is a method that allows you to really maintain the freshness or of the data in your local data store, close to within minutes of when Yodlee has the data, and you can use this method to maintain under that 3 accounts per second limit for up to 100,000 users, and we'll get into an example of how this works next. So, starting off with the new Yodlee Data Extract product options, we have 4 of them, and we're now tailoring this solution based on customer needs. So the one we're going to focus on is synchronized data API extracts, and this method is really intended for customers who want to use the API. They don't want to have multiple interaction points with Yodlee via files and an API. They're looking for data freshness to be as optimal as possible, and they're looking for a relatively low implementation effort. So this is the one we're really trying to promote for our customers to use. Another method, the second method for API data extracts that we have available to our customers is called schedule API data extracts. This is a little bit more traditional, but we are opening up product options that allow where we can negotiate with the customer on finishing our own background refreshes or our cache refreshes at a certain time, and then working with customers on a time window for when they can come in and extract the data and lifting the 3 accounts per second. So that's another option. The data still could be up to 24 hours out of date from what Yodlee has in our own local database, but it is an option that we're offering. And then we have our traditional file-based data extracts, but we're splitting this into 2 categories. One is file-based data extracts for analytics, and this is for customers who want the data, but they really don't necessarily need the data to be available or that fresh. This is for people who are using the data more for analysis purposes rather than for display purposes, and there's a lot of leeway there on how fresh the data needs to be. And then there's file-based data extracts for online, which is more tailored towards synchronizing how the timing for when we produce the files and with when we finish our extract, and producing a file that happens right at the end of our processing. So let's get into more details about the Yodlee Data Extracts API. Now, if you look at the bottom of this slide, you'll in the area where it says Yodlee Refresh Services. So our standard cache run happens from 10 a.m. Pacific to 5 a.m. Pacific. That's when we do our refreshes. And essentially, we spread our refresh process over that entire 19-hour window for the entire day. That's our standard implementation. If you're a new customer with Yodlee, that's the way that the cache run is going to be set up from the get-go. Now, the way our system works is we refresh the accounts, and we have an example here of we're refreshing an item at 6 o'clock p.m. on day 1. And the next refresh for that item is scheduled for 4 o'clock p.m. the following day. So the following day, the cache run will happen, and that item will be refreshed at 4 p.m. Now, the new method that we're working with our customers on, synchronized data extracts, involves using a client flow. And so, put your eyes to the top or upper half of the slide where it says client API calls, and you will. So the flow here is you log in, you call get item summary for item, you call transaction search to get so you're grabbing your account data, you're grabbing your transaction data, and then making a subsequent call called get refresh info. And the get refresh info API will tell you when we're going to refresh that account the next time. So if you go on, our method here is that we're giving customers the ability to capture and store in their local database the timing for when we're going to refresh the account next, and then ultimately to schedule your time for when you go and extract that data in conjunction with when we go and extract that data. So that if you look over to the upper right-hand corner, we have scheduled the next refresh for the particular item at 4 p.m. the following day, and as a customer, you come in at 5 p.m., give it an hour buffer, come in at 5 p.m., log in, call get item summary from item, transaction search service, get refresh info, and you're going to have the update date data within an hour, or we could even do it closer to that, of when Yodlee has the data. And you'll have the next refresh time from the Yodlee side as well. And this will work even if the item returns in an error code. You'll see when the next refresh time is set to process that error code. So imagine if the site, when we refresh the data, we got a site error, and we would go and retry that refresh for the site maybe 2 to 4 hours later. You'd actually have the time for when we're going to do that retry, and you can have your system automated to come back in and look for the timing after we refresh the account. So hopefully that makes sense. So the next slide here shows how does this scale, and why are we so stoked about this particular solution. So you see we have our cache run set from 10 a.m. to 5 a.m. At the bottom half of this slide, we're showing that where the client extract would then happen from 11 a.m. to 6 a.m. So this really is a good illustration of how this process scales so well. So we're doing our cache run for 19 hours, and our customers are doing the extract over 19 hours and really coming in and grabbing the data just right after we have refreshed the data. And for those of you who are math fans, I've included a little bit of 7th grade algebra for everyone here. So here's a scenario where imagine you have 100,000 users in your system, and you have an average of 2 items per user. Now, if you take 100,000 users and you have 2 items per user, that's 200,000 items that you're going to be extracting per day. And now if you divide that by 19 hours, a 19-hour window, that comes down to 2.9 items per second. So you can see pretty well that this solution is kind of built. It's built for people to have the ability to extend out the time for which they can use API extracts before you need to actually purchase the Yodlee DataExtracts product. So it scales really nicely, and we're pretty excited about it. So in terms of API data extracts timeline, this capability is already available. The Get Refresh Info API is available to all of our API customers. We do have our first sets of customers that are starting to implement this method of synchronized data extracts with us already. But the product documentation is still lagging behind. So stay tuned for this. In this summer, we will be updating the YI website with product documentation, as well as some sample applications that show how to use this method. And for the future, 2015, we're also currently planning in our product some even new and improved APIs to make this whole flow and process easier. So this is something we're really committed to doing better for our customers. And that's it for our content, and we're opening up to questions.
Thanks, Jeff. Those were some really great tips and guidance you just shared. So now we're going to open up to our broader audience for Q&A. So if you'd like to ask a question, go to the top part of your WebEx window, pull the drop down, you'll see a section there for Q&A. You'll look for that Q&A button. In the meanwhile, Jeff, we did receive some questions in advance, so I'm going to shoot some of these out for you now. So question number 1, can you please explain why you time out co-brand session tokens?
Yeah, this is a good question. The reason we time out the co-brand session tokens is mostly for security reasons. So, we as a financial provider, Yodlee we really get graded by auditors as a financial institution. So we go through countless audits every year for security audits through our security program every single year to prove out our security and at the financial institution level. Now the best practice or what the auditors are looking for is they want you to generally time out something like a co-brand login within 24 hours. And our goal is really to beat all of our meet and exceed all financial audit expectations. So we just set this 2-hour time frame for our co-brand login API from the get-go, and we've maintained that time frame as a timeout ever since for a long time standing. And it's really a way for us to continue to do a great job with our auditors and passing our finance audits. That's the reason.
Great. Next question. How does MFA integration work while adding or refreshing accounts?
how does MFA integration? So I'm gonna for the purposes of this call, I didn't put any time into the MFA calls, but I do want to. This question does seem very much like, I think we do get a lot of comments on the performance of the Get MFA Response API call and the Get MFA Response for Sites API call. So I will address that here. In terms of best practices for the Get MFA Response API call, there's really nothing that a customer can do to make this API call faster. You're very much you can follow the documentation on our website for how to use the API call, but there's not much that a customer can do to make it faster. The Get MFA Response API call, the average response time across our network is about 6 or 7 seconds. And really, we're at the mercy, part of it is we're at the mercy of how fast the sites are. And, we support well over 10,000 different financial institution sites, and many of them have MFA. And so some of those, you'll get a 1 or 2 second response time on Get MFA Response for the initial part of the login. Some of them take 10 or 15 seconds and even get up into the 20-second range. And we do get a lot of comments about that response time. And now we are doing some things to try to improve the response time, and my expectation is that within the next year we're going to be getting that response time of Get MFA Response down, and I'm hopefully want to improve it, at least make it improve the response time by at least 2x what it is now, or improve it by and cut the response time in half. So a couple of things we're doing right now. We're actually going through a hardware infrastructure refresh of our gathering infrastructure, and that's currently a project that's going on and will complete by the end of 2014. So right now, half of the refreshes that happen in the Yodlee network are on our new gathering infrastructure, which has a flash component enabled in it, which does help with the performance of our gathering. So that's one thing we're doing that's going to improve the response time of MFA. The other thing we're doing is we're doing an application refresh, and we're rolling out a new gathering application architecture as well. And that's just starting to roll out right now, and will continue to roll out through mid of 2015. We also expect that to improve the MFA performance.
Great. Can I add Link Account Wizard or FastLink in my app? Will it be faster this way?
You can add Link Account Wizard or FastLink to application. In fact, we do recommend for customers to do this. I mean, we've spent a lot of time building the FastLink product, and so rather than having to build on your own your method for aggregating accounts, we do recommend just using our application for doing so. However, there really is no performance gain from going to Link Account Wizard or FastLink versus using the API to do so. Most of the latency that's involved in refreshing an account has to do with the time it takes to refresh the account, and has very little to do with the application of the API. So there really is no performance gain on the end-to-end response time of refreshes from going to FastLink.
How often can I call Refresh Account API?
So the absolute time for calling the Refresh Account API for a user is 15 minutes. So we have a control in our system that after we refresh an account for a user, we do not allow another subsequent refresh for that account until a 15-minute period afterward. In terms of your ability to call the Refresh API, the way things are set up contractually is we want people, we forbid people from doing an automated refresh process. The way things are set up, we want people to leverage the Yodlee process, or the Yodlee cash run for refreshing accounts, and to use the login API when there is a user on the other end. There are no limits for how often you can call the login API when there is a user on the other end. If you've built your application, application and provided the ability for a refresh at login, or for the user to trigger a refresh. The user, if they log in 20 times in a day and they trigger a refresh every time, we're totally fine with that. But we definitely do not allow for you to create a batch job to refresh the accounts over and over again.
Can you clarify if our platform, this developer's platform, is distributed across several physical servers? Can each server use a private cached COB login, or do all servers need to use a single global session token?
If your developer, from a server side in Yodlee, your developer environment is distributed across multiple servers. If you can use, and essentially the API access is load balanced across those servers. For us, it's totally, we can have one server or 100 servers servicing requests, and we will accept the co-brand login token for that user. So no issues there from the server side. For your processing, it's actually up to the customer implementation. If you have the ability to do have a single cache across multiple client instances of the API, you can go ahead and reuse the co-brand session across many servers on your side, or you can cache the co-brand session per each instance. It's really up to the customer implementation to make on what works best for you.
Great. Next question here. When submitting a new login for an institution, how long will Yodlee attempt to connect to the bank before timing out? I'm curious how long I should be waiting around for a response and sending this login call.
This pertains to, I think this pertains mostly to the get MFA response. The default timeout is, I believe it's 120 seconds. Is that?
It's 5 minutes for refresh.
Okay, well, it's 5 minutes. The default timeout is 5 minutes. Some of our customers have asked us to change the timeout, and a lot of our customers do implement their own timeout at 60 seconds. Admittedly, 5 minutes is a very, very long time to wait for a login. And, I would, to be quite honest, I would not recommend people to wait to have a 5 minute timeout on their end. But that's what our timeout is. We will time out the refresh after 5 minutes. But typically we tell our customers to maybe put in a 60-second or a 2-minute timeout for a login. That's a really long time.
Okay. I've got an API question here. Upon linking an account for the first time, is there an API that would first validate the credentials that a user supplies before calling refresh?
Yes. Well, the get MFA response does do a first round validation, because it does log in, it does test the login, and then it does either 3 paths. It will return back. If it gets through entirely, it'll return back that, hey, I'm through. There's no additional challenge, and we're proceeding with the refresh. So through the get MFA response API, you actually will get a response back, that hey, the refresh is going through, and now you just need to use the polling API to look for the final response. If there is an MFA challenge question that comes back, you'll get that initial login verified. Now, if it is not an MFA account, then our older version of our product, you have to really wait for the entire refresh to go through before you get a confirmation. And at the end, you get the confirmation that the refresh succeeded. We are implementing, and it is implemented as part of the newer new FastLink product. We do return back a confirmation that the login succeeded, and the refresh is now done in chunks, and you are getting back statuses of when we log in. And we're also implementing some additional features called progressive refresh that's going to come out in another 6 months or so that has even better statusing of where the refresh is. But the FastLink product does provide the capability of knowing where the status is of the refresh.
Okay. So we've got time for just a few more questions, and then we'll wrap up. Next question, Jeff talked about concurrent logins. In the API, you have the option to make sessionless versus session-based calls. Just to confirm, Jeff, would you recommend session-based? Does using the API sessionlessly result in concurrent logins and degraded performance?
The answer is no, and it's the sessionless versus session calls is a preference. So we really leave that up to the customer to make that decision. Making sessionless calls will not degrade the performance of the API. Now, what I do want to note here is that say for instance, if you lead off with a data service call and you make a sessionless call, it will include the response time of the login within the data service call. So it'll make the data service call look like it took a little bit longer the first time around. But there's no issue with using the sessionless call, and there's no where you can run into issues is if you're making multiple sessionless calls concurrently. There can be a slight amount of contention, but in general, it's not an issue. And if you decide to use sessionless calls.
Great. What happens when 3 accounts per second limit is exceeded? Do calls get rejected?
Currently, no. Currently, we do report on this, so we do know what people are doing in our system, but we really do, even though it's in the contract on 3 accounts per second, and again, it's actually 3 items per second that we're looking at. We do pretty much rely on the honor system, and a lot of times when people are exceeding the 3 items per second, we will, reach out to them and have a discussion about what next steps we want to take on resolving and have deeper discussions about how the API is being used, and more and more these days we're getting into discussions about hey, do you look at maybe using this synchronized API methodology.
Great. And then one last quick one. Do you refresh accounts which have invalid credentials? Could cause a lockout of the account. No,
we don't.
Okay.
Once an account has invalid credentials, our system will not do a refresh, and we rely on an interaction with the end user via our edit account APIs to reinitiate the credentials and retry the refresh.
Great. Thanks so much, Jeff. That was an awesome webinar today. This concludes today's webinar. Thank you all for attending. You'll be receiving an email in the next few days with information on requesting a recording of this webinar. If you'd like to get additional information, and meanwhile we'd like to schedule a more in-depth presentation, please respond to the email and we'll direct you to our solutions team. Thanks again, and have a great day.